Welcome to Programming with Professor Caleb. In this series, I've talked quite a bit about arrays in Java. Today, I want to expand that to multi-dimensional arrays, especially two-dimensional arrays. Why do we need two dimensions? After all, if we have a plain old array, we can generally store as many items of a given type as we need. Well, there are a lot of places where we end up with a table of data, something with rows and columns. There are lots of examples in games and puzzles. So think about Scrabble or chess or checkers or tic-tac-toe, Battleship, Sudoku, mazes, word search puzzles, crosswords. We go on and on and on. We also may need a table of data where we need to read or display or process that data in some way. This could include things like grades, where we've got students and we've got assignments, or sales data where we might have different regions and different quarters, or different salespeople in different quarters, or different items. Lots of different possibilities there. Anytime we have something that is probably most easily represented in a spreadsheet, that could be a candidate for a representation in a two-dimensional array in our program. Then sometimes we just need matrices because we're doing that kind of math. One example where that's very important is in using neural networks, the basis of deep learning. That uses matrices heavily in the math required to do the learning and to simply use the neural networks. How do we actually use our 2D arrays? In Java, we actually only have one-dimensional arrays. So that might seem to make this all moot, except that we can create arrays of arrays, and that ability allows us to create tables or matrices. So let's take a look at how this actually works in code. So I have here a file matrixpractice.java for us to work in, and let's start by simply making that a class. So use some of the nice capabilities. Let's see, this is a program to practice with multi-dimensional array. Well, we're going to practice with 2D arrays. And I am writing it. So, just going to work in main. So let's get Visual Studio Code to pop that up for us. First thing I want to do is simply declare and create an array. I'm going to make it a 3x4 array. Let's declare that int. I'm just going to use int arrays because they're nice and simple. And then I'm going to have two sets of square brackets. So it's an array of arrays. So an array of events. And I'm going to call this matrix. And now I'm going to actually create this matrix, and I'm going to say int, and we'll make it an array of 3 arrays of 4. Let's actually see what it looks like to do something. So that actually declares my two-dimensional array and creates it to be a 3x4 array. Now, as you might guess, with arrays, with these two-dimensional arrays, we tend to use a lot of nested for loops because we want to walk through both sides. So let's take a look at that. For int is 0, 0. I is less than, the outer was 3, I plus plus. And then for int j, very common to use j for the second counter. J is less than 4, j plus plus. And I'm going to simply put the sum of I and j into that cell of the array. So matrix I j is assigned I plus j. Now, of course, that's not terribly interesting because we can't look at it much, but let's go ahead and just put something in here to break on. So I'm just going to put a print line statement and put a break. Oh, let's actually put a break up here. So break, and I'm going to debug this. I'm going to open our debug so we can watch the local variables. So far we don't really have anything, but let's create it, and now we can see the matrix. And I'm going to expand this a bit so I can expand each of these. And you can see I've got 3 arrays of type int that are 4 long. So if I expand that further, I've got things with zeros, because anytime we create a new array, it's going to be filled with zeros unless we have initialized it somehow. And so we have 3 of those. So now let's see what happens with these as we step through here. I'm going to pull this down. It looks like that's as much as it will let me expand it. So let's start stepping. Of course, we now have I down here at 0. We've created a J, it's 0. So now we go, and now if we look at this, well, 0 plus 0 is 0, so nothing changed. But let's do this next one. Now J is 1, and we're moving, and we can see that this is now 1, this is now 2. As we do the next one, this becomes 3. Now, one thing to note here, just a useful thing to go back to, J is now gone. And as we go through, we have 1 and 0, and this has become 1, and that's become 2. And we can see each of those changing. And now in the third one, of course, we'll have 2, 3, 4, and 5. Okay, let's now go ahead and make that finish off. Won't take long. And let's actually print this out so that we can see it. Now, as we do this set of for loops, I'm going to make one change to them. I'm going to actually just copy and paste, because I don't believe in writing more code than I have to. But I'm going to change this. So instead of 3, we're actually looking at the size of the array. So I can still do that. Matrix.length is 3. And now for the J, I need the length of the current row. So what I'm going to say is matrix at I dot length. And that then is going to be 4 for each of these, because they're all of length 4. So in this case, we're not going to reinitialize it. What I want to do is print it. So we're going to system.out.print. And in order to get things spaced off, I'm going to put a space there, and then matrix at I at J. And then to make this look like the table that we have in memory, I'm going to add a print line here. And this is going to look like some of the nested for loop things that we've done, where we've just been printing with the nested for loops, not using something that was stored in the computer that way. But we're still doing similar things when we go to print out one of these 2D arrays. So now I'm going to get rid of the breakpoint here and just run this. And we'll see that it prints exactly what we saw being stored into the 2D array. And the lengths were the correct lengths. I want to do another 2D array and show you how we can actually initialize. So just like we initialize one-dimensional arrays, we can actually initialize two-dimensional arrays. So let's make another array here. we'll call this one table. But instead of saying new int and setting it up that way, I'm going to use our initialization capability. But because this is 3 different arrays, it's an array of arrays, I'm going to have multiple sets of curly braces. So I'm going to make this a 3 by 3 array that just has the numbers 1 through 9 in it. 7, 8, 9. I'm going to format this. So we can see we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So each of these is initializing its array. And then we have the initialization list for the whole thing. And let's actually put that semicolon in. Then it throws in all the spaces to make this more readable when I format it. So we can see each of the lists for the inside the inner arrays, and then the overall list that contains those arrays for the outer array. So as long as you've got a small enough table, you can initialize it just like you can a smaller one-dimensional array. Okay, let's actually print this. I'm going to copy our existing print code and place that after the extra print line, and change this so that it's printing table instead of matrix. And let's see what that looks like. Let's go run that. And you can see that it prints out the 1, 2, 3, 4, 5, 6, 7, 8, 9, because it knows how long the thing is. I do want to show you something else real quickly in terms of parameters. So we can use 2-dimensional arrays and parameters just like we do 3-dimensional arrays, or 1-dimensional arrays, and 3-dimensional arrays. So I'm going to actually create a public static. Actually, let's let them make it for us. Okay, so we make this void, and this is print 2D array, and so we're going to have that, and this is the array to print. Let's copy this print code. Actually, let's just move this print code in here, but we're going to be printing the array. And now let's replace this old in its place. We're going to put the print 2D array table. And we're going to wipe out these for loops and replace that with print 2D array and pass it the matrix. So let's run that again and make sure that it behaves just the same way. And you can see that, drag this up a little bit, you can see that the 3 by 4 array got printed and the 3 by 3 array got printed with that same code. So just as we can pass other things around, including our 1-dimensional arrays, we can actually pass 2-dimensional arrays as parameters. No problem at all. So I do want to talk to you a little bit about another concept, which is the jagged array. So one of the things that's kind of convenient is that because our inner arrays are just arrays, we don't have to make them be the same length. And this is not really commonly used, but it is sometimes quite helpful. So let's pop back again and see about doing something where we have different lengths for our different rows in the array. So what I want to do here is to actually create a table that is maybe months, high temperatures per day per month, but I want to store it in a 2-dimensional array where each row represents a month and the columns are the days, But I don't want to have to make it 12 by 31. I want to make each row the correct length for that month. And we're going to assume no leap years here. So that's still going to be an int two-dimensional array. And I'm going to call that high temps. And I'm going to create this, but I'm only going to create the outer array. So what I'm going to do there is I'm going to say int 12, because I have 12 different months. But then I'm just going to use, if I can hit the right keys, I'm just going to use an empty set of brackets for the inner part. So I've created this array, but it's an array of arrays that don't exist yet. So now I can actually create each of those arrays individually. So I can now say high temps at 0 gets new int 31, because January has 31 days. So my first month, 31 days. And I just make this, it's just an array of ints that happens to be stored inside another array. And I can do this for several months. So let's do it for a few. Let's see, we've got January's 31, February has 28, March has 31, April has 30, and May has 31. And of course we could keep, let's make that 4 so it's correct. And we could keep going, but what I'm going to do here, rather than spending a lot of video time, is to go ahead and just make this the first 5 months. Now what I want to do is to actually print this one, and I'm going to comment out our old code here and just call our print 2D array and pass it high temps. Now what we should see here is arrays of zeros, because we haven't put anything in this besides the initial zeros that it would start with. But we should see them of the appropriate length for each month. So let's go ahead and try running this and see what we get. And if we pull this on up, scroll down, we actually do have, you'll notice there are 3 more days here than there are here for 29, 30, 31. Technically speaking, of course, this is index 28, 29, and 30. 28 days, 31 days, 30 days, 31 days. So notice that this works fine, and our print array works fine because it is looking at the actual length of each of those inner arrays as it goes. So it's not assuming anything about how big each inner array is. As I said, not a really common thing, but kind of cool. Our final question here should be whether we're limited to just 2 dimensions. And the answer is no. We can have more dimensions, even many more. We can make arrays of arrays of arrays of arrays of arrays, as many as we need. In practice, you won't often see more than 3 dimensions because you just seldom need more. But if you do have a need for more dimensions, you can have them. Thanks for watching. In the next video, we're going to switch gears a bit and introduce inheritance, a very useful object-oriented concept.